Hello students, in the last video we discussed about the basic part of data structure. That means definition of data structure and classification of data structure. And in this video we'll discuss about the types of data structure and their explanation. Primitive data structure. Types of primitive data structure. In that first is integer. These primitive data type hold integer value like int, short, long, byte, etc. They typically requires 4 byte of memory space and ranges from minus 21472 plus 2147. Second is character. These primitive data type hold characters. They typically requires 1 byte of memory space and ranges from minus 1282 plus 127. Third is float. These primitive data type hold fractional value. They requires 4 byte of memory space. Fourth is pointers. This primitive data type holds a memory address. Okay, these are about types of primitive data structure. Integer holds integer values, character holds characters, float holds fractional values, and pointer holds a memory address. Types of non-primitive data structure. Arrays. An array is a collection of homogeneous elements with unique name. Means it is a collection of same type of elements with a common name. Okay, homogeneous elements with unique name, we call it as arrays. These elements are arranged one after the other in adjacent memory location. Okay, elements in the array are arranged one after the other. The data items in an array, we call it as elements, and the elements are accessed by numbers and we call it as subscripts or indices. Since array are accessed by subscripts, we call it as subscripted variables. Okay, there are three types of arrays: one-dimensional array, two-dimensional array, and multi-dimensional array. These are the three types of arrays. One-dimensional array. An array with only one row or a column, we call it as one-dimensional array. The name itself says array with only one row or a column, we call it as one-dimensional array. It is a finite collection of n number of elements of same type such that elements are stored in contiguous locations. Elements can be referred by indexing. Syntax for one-dimensional array. This is the syntax: data type, array name, size. Okay, where data type is type of value it can store. Okay, here in the data type we can write the type of value, that may be integer, character, float, etc. In the array name, to identify the array. That means if we write a program, we have to identify a particular array. For that we have to name it. That's why the array name indicates to identify the array. Size means the maximum number of elements that the array can hold. We write it in the size. This is about the syntax of one-dimensional array. This is how we represent the array. Example, int a of 5. Here int is the data type, a is array name, and 5 is the size of the array. Here address of the array, content of the array and location of the array is represents. 1000, 1001, 1002, 1003, 1004. These are the 5 addresses for the given array. Content A, B, C, D, E, and the location we represent like array of 0, 1, 2, 3, 4. And where A of 0 is the lower bound LB and A of 4 is the upper bound UB. Okay. The features is array size should be positive number. Okay. And the string array always terminate with the null character. This is the features. Calculating the length of the array. A of n, the number of n is called the size or length of the array. Okay, the length of the array can be calculated by using L is equal to UB minus LB plus 1. Length is equal to UB upper bound minus LB lower bound plus 1. UB is the largest index and LB is the smallest index. Okay. Example, if an array A has values 10, 20, 30, 40, 50 and stored in 0, 1, 2, 3, 4, then the UB is 4 and LB is 0. So, according to the equation L is equal to UB minus LB plus 1, we get L is equal to 4 minus 1, 4 minus 0 plus 1, that is equal to 5, right? 4 minus 0 plus 1. So, this is how we calculate the length of the array using the equation L is equal to UB minus LB plus 1.